Hello there and welcome to the Science for Sleep tonight. We are heading into the science behind one of the most beautiful sights on Earth, the Northern Lights. High above the world, rivers of color drift across the sky, glowing in silence, twisting and shimmering like living spirits of light, turning the darkness into something almost alive. For centuries, people have stood in awe beneath these green, red, and violet waves flickering over frozen lands, wondering what mysterious forces painted the heavens. Somewhere beyond our atmosphere, a cosmic story unfolds, a conversation between Earth and the Sun, a dance of charged particles and magnetic fields that transforms invisible energy into radiant color. The aurora is far more than just lights in the sky. It is a breathtaking dialogue between our world and the star that gives us life, a meeting where the breath of the sun brushes the edge of our planet and leaves the night glowing with quiet wonder. As you listen, just breathe and imagine the sky unfolding around you, the vast dome of night alive with motion and color. The northern lights begin with energy from the sun striking our atmosphere. High above the clouds lies a silent ocean of atoms and molecules waiting in stillness. Into this sea, charged solar particles arrive from space and dive into the upper atmosphere, colliding with oxygen and nitrogen. These collisions pass energy like a spark between hands. The atoms absorb it, leap into excited states, and then fall back, releasing that borrowed energy as light. From the ground, we see the faint afterglow of countless microscopic meetings, each collision a tiny lantern turning on for the briefest moment. The night sky becomes a tapestry woven from quantum dances invisible to our eyes until they blossom into color. The spectacle is vast, yet its essence is intimate, an exchange happening one particle at a time. When these interactions sweep across the heavens, it feels as if the universe itself is breathing, and the world below is caught in its rhythm. Every hue we see in the aurora is the signature of a different atom writing its name across the sky. Oxygen paints in greens and reds, revealing its inner structure through the wavelengths it releases. Nitrogen prefers purples and blues, spreading cooler tones that edge the darkness with delicate fire. The atmosphere is not a single canvas but a layered gallery, each altitude hosting its own palette and rules. Atomic structure decides which shades appear, which transitions are permitted, and which remain forever hidden. In this frozen theater above the mountains and lakes, chemistry turns into choreography. Colors drift and twist, fading and reappearing as atoms relax and rest once more. To the eye, each tone becomes a clue, a map revealing who is glowing and at what height that glow is born. The night becomes both mystery and revelation, a living manuscript of physics written in light. The green aurora, the most familiar and vibrant, comes from oxygen about 100 kilometers above Earth. There, the air is so thin that excited atoms can hold their light for a lingering moment before collisions extinguish them. In that pause, the emerald radiance spreads across the horizon, forming ribbons and waves that pulse with the planet's breath. Green gathers along arcs that spill into curtains seeming to sway like silk in slow motion. Human eyes are especially sensitive to green in dim light, so it captures our attention first, tracing the soft edges that curl and twist across the stars. The world below remains frozen and silent, yet the heavens hum with a quiet brightness that makes snow glisten and rivers glint faintly with hidden color. Under this light, even the coldest winter nights feel warmer, as if the earth itself glows from within. Higher still, where the air thins almost to nothing, oxygen glows red. Here, collisions are so rare that atoms can hold their excited energy for many seconds before releasing it. The result is a soft crimson veil hovering at the roof of the atmosphere, spreading like a gentle fire that crowns the auroral display. This red light moves slowly, ghost-like, flowing at the edge of space, while the bright green lanes dance below it. Sometimes the red pools near the horizon, like distant embers in the night. Sometimes it cascades downward in faint sheets that whisper of unreachable distances. Watching it feels like standing beneath an ocean of thin air, sensing the vastness between Earth and the stars. The red aurora tells a story of patience, of light released only when the sky grows still enough to let it be seen. Deeper in the atmosphere, nitrogen molecules add their own strokes to the painting. When struck by electrons, they emit purples and blues, especially in the faster, lower regions of the aurora where energy rushes through with intensity. These cool tones edge the green curtains like frost along leaves, appearing in racing fronts and sharp folds that shift rapidly with bursts of energy. Each nitrogen molecule spins and vibrates, turning collisions into flashes of icy light that flicker and fade almost before the mind can register them. To the eye, they form outlines and striations, fine threads stitching across the flowing curtains. Together, they give the aurora texture and depth, making it feel three-dimensional, a living sculpture in motion. The blues and purples mark colder air and quicker lives, brief sparks that flare and vanish before thought can catch them. Yet every aurora, no matter its color, begins the same way, with a storm on the sun deep inside that fiery star. Tangled loops of magnetic energy twist, snap, and release vast bursts of plasma into space. Sometimes the solar wind blows steadily, and sometimes it erupts violently in a coronal mass ejection, a giant gust of charged particles carrying magnetic fields across the solar system. When this solar breath reaches Earth, the encounter becomes a cosmic negotiation. Earth's own magnetic field stands guard, deflecting most of the solar wind but allowing some energy to seep in through its open gateways. When the two magnetic fields align just right, energy pours into near-Earth space, filling it with restless plasma and setting the stage for auroral light. Hours or even days after a solar eruption, the night sky above the poles begins to glow. What we see as color is the echo of that faraway upheaval, sunlight transformed into a silent, shimmering conversation. The Earth's magnetic field guides these charged particles toward the poles. Imagine invisible lines of force arcing from the southern hemisphere to the northern, curving through space like glowing rails. Particles spiral along these lines, bouncing between magnetic mirror points until they find openings that lead downward into the atmosphere. There, they collide with air molecules and ignite the display. This geometry explains why the lights appear in rings around the magnetic poles, and why their patterns shift when the field itself is. The magnetic field acts both as shepherd and gatekeeper, channeling certain particles while filtering others by their energy and direction. To look at an aurora from afar is to glimpse Earth's magnetic field made visible, a living map of invisible forces drawn in color. The poles are not just points on a globe, they are breathing portals through which the planet's magnetic life flows, guiding travelers made of light. What makes this phenomenon even more extraordinary is that the northern and southern lights often dance in perfect symmetry. When solar energy enters near-Earth space, it threads along field lines that connect one hemisphere to the other, creating twin auroral ovals that mirror each other across the planet. As the energy flows, both skies respond, brightening, rippling, and fading together, partners in an ancient and silent duet. In this shared rhythm between sun and earth, between north and south, lies a reminder of the deep connections that bind the universe. The aurora is not merely a spectacle, it is evidence of cosmic intimacy, proof that even across millions of kilometers, the sun and earth remain in constant dialogue. To stand beneath the northern lights is to witness that conversation, to feel the pulse of solar storms translated into beauty, to sense the magnetism that shapes our world, and to remember that we live within the reach of a star's breath. When you gaze upward and see green ribbons unfurling like silk, red veils floating above them, and faint blue sparks flickering at the edges, you are watching atomic whispers turned into light. You are seeing the invisible become visible, the physics of the universe revealed in poetry. The aurora reminds us that our world is alive with unseen forces, that even in silence, the cosmos is speaking, and that in the glow of the northern night, science and wonder become one and the same. From above, the northern and southern lights appear as twin garlands encircling the poles, shimmering halos bound together by the same magnetic and electric currents that weave through Earth's atmosphere. Yet, even in their symmetry, they are not perfectly alike. Subtle differences in the magnetic field, the tilt of the planet, the changing seasons, and the direction of the solar wind cause one to stretch or twist differently than its counterpart. Still, when a wave of color rises in the north, it is almost always mirrored by a similar glow in the south, separated by an entire planet yet linked by an invisible magnetic thread. This vast mirror dance between hemispheres reveals the planetary scale of the aurora, reminding us that these lights are not isolated local phenomena, but immense global sculptures painted by the unseen forces of the magnetosphere. The auroras trace the paths of invisible magnetic field lines that run east to west, forming the delicate arcs and curtains we see from the ground. Each graceful ripple mirrors a change in the geometry of space above us. When the field lines twist, so do the lights, and when they kink or flutter, the sky responds with folds and braids of color. Plasma instabilities sculpt the display, pulling the lights into thin, luminous strands, flattening them into wide sheets, or twisting them into ropes that flow across the night like illuminated rivers. None of these shapes are random. They are living imprints of the structure and motion within near-Earth space. If one could paint the magnetic field lines themselves, the brushstrokes would match perfectly the arcs and folds seen in the sky. Even the bright knots that race along a band of light, the little beads that seem to chase each other over the horizon, are following these hidden tracks of energy. Far above weather and cloud, the geometry of magnetism directs every movement. Watching the shapes change is like reading a cosmic language, a visible story of moving forces that normally exist only in the language of equations and plasma waves. What looks calm and graceful from below is, in truth, a dance of electrons moving at near light speeds. These electrons surf waves in the plasma, riding bursts of energy that sling them downward toward the atmosphere. When they strike the thin air, they ignite brief flashes of light that flow together into ribbons and curtains. The human eye interprets this as motion, as if the light itself were alive, sprinting and breathing across the horizon. In reality, it is countless microscopic impacts unfolding faster than we can perceive, each one leaving a trace of glow before the next follows. The result is movement that feels almost conscious, ribbons that curl, waves that twist with fine, lace-like edges, and surges that ripple outward like wind racing over water. Even when still, the aurora carries a sense of potential energy, a readiness to burst into life with the slightest change in the magnetosphere. When magnetic fields snap and reconnect, they release stored energy in tremendous bursts. Far beyond the clouds, in the stretched tail of Earth's magnetosphere, magnetic lines of force twist and tighten like drawn bows. As pressure builds, these lines break and reform, flinging energy through space in every direction. Though silent, this invisible storm sends torrents of charged particles racing toward the poles. When they meet the atmosphere, they ignite it, an enormous match struck in slow motion. Curtains of light bloom outward, unfurling across the night sky as stored cosmic tension becomes color. Each burst of brilliance is a visible signature of magnetic reconnection, the same process that drives solar flares on the sun and powers plasma jets around black holes. For a few extraordinary moments, the quiet sky transforms into a canvas for one of the universe's most profound exchanges, geometry turning into energy, energy into light, and light into motion that seems almost alive. Sometimes these auroras appear as wide, smooth curtains swaying gently, while at other times they sharpen into crackling ribbons that twist and braid with furious intensity. The difference lies in the flow of energy. When the influx of particles is steady, the aurora glides softly like silk on a slow breeze. When the solar storm intensifies, plasma channels narrow, and the smooth sheets fracture into thin, bright filaments that dart and coil across the heavens as if drawn by invisible fingers. To the human eye, it feels as though the atmosphere itself has grown texture, a tangible fluidity one could almost reach up and touch. Each form tells part of the story, one calm and continuous, the other wild and electric. This contrast reveals how subtle shifts in unseen cosmic currents can sculpt chaos into beauty, shaping the same energy into countless dynamic forms. During powerful magnetic storms, the aurora can shimmer 10 times per second, flickering like a living flame that breathes too quickly to follow. These rapid pulses sweep through the plasma, modulating brightness and rhythmic flashes that feel musical in their precision. To the naked eye, they appear as vibrating ripples, a strobing dance of energy too fast for conscious thought to track. High-speed cameras show that these pulsations are not random. They are driven by oscillations in the stream of charged particles pouring from space, each pulse marking a heartbeat of interaction between the sun and the Earth. It is a dialogue of electrons and fields, translated into a language of light. To stand beneath such a display is to witness the universe thinking in real time. The entire sky seems aware, blinking and breathing in patterns that hint at meaning just beyond human understanding. Behind its tranquil beauty lies motion at impossible speed, a constant communication of energy between a star and the planet it warms. From space, the spectacle grows even more breathtaking. Astronauts aboard the International Space Station look down upon the aurora as if gazing upon a living ocean wrapped around the world. The lights do not rise above the horizon, they circle the Earth, forming vast rings of emerald, violet, and crimson that ripple across the upper atmosphere. From orbit, the arcs drift beneath them, revealing the curve of the planet outlined by shifting glows. Sometimes the station flies directly through the upper edges of the aurora, where faint light surrounds the spacecraft like mist that breathes with its motion. In those moments, the boundary between Earth and space seems to dissolve. Looking down upon the aurora from above is like seeing the planet crowned in light, a living halo of magnetism and energy, proof that our world is not silent but alive with cosmic breath. A single aurora can stretch across thousands of kilometers, dwarfing mountains, oceans, and entire nations. From space, its true size is staggering. What appears from the ground as a distant arc may in fact extend from one edge of a continent to another. During intense geomagnetic storms, the glowing ovals at each pole can widen so much that they nearly encircle the Earth, forming complete rings of light. This immense scale arises because the energy that drives the aurora flows through the entire magnetosphere, guiding charged particles along field lines that connect vast regions of the planet. On clear Arctic nights, people separated by hundreds or even thousands of kilometers may unknowingly stand beneath different parts of the same colossal luminous structure, united under a shared cosmic canvas. The aurora connects landscapes and cultures beneath a single sky, bridging continents with light. Its true size defies imagination, a phenomenon so vast no single person can see it all, reminding us of the global reach of invisible forces that sustain the dance. Cameras reveal a world our eyes cannot perceive. Human night vision, tuned for survival rather than beauty, is blind to the deepest blues and purples of the aurora. What we see as soft greens and reds is only part of the spectrum. Digital sensors, patient and unblinking, collect light over time, gathering faint photons the eye cannot. In long exposures, hidden hues bloom, indigo streaks, violet pillars, azure threads weaving among the emerald waves. These tones unveil the complex chemistry of the upper atmosphere, showing how each altitude and element contributes its own signature to the grand palette. Photographs that seem surreal are, in fact, truer than sight. They show the world as it is, not merely as our senses allow us to see it. Looking at those images later, one realizes how narrow our perception is and how astonishingly rich the universe becomes when light is allowed to speak fully. Despite their visual intensity, auroras are silent. They ripple and crash across the heavens like a celestial symphony played in perfect quiet. The air is too thin for sound to carry, and so the display unfolds without a whisper. Beneath it, the stillness feels immense, the silence so profound that it seems to amplify the heartbeat of the watcher. This absence of sound heightens the spectacle, creating an almost sacred contrast between visual motion and audible emptiness. Ancient peoples filled the silence with imagination. They believed they could hear the lights whispering or singing, the voices of ancestors or spirits carried on the wind. The mind, confronted with such grandeur and quiet, invents its own symphony. The silence becomes music internalized, a rhythm that beats in the observer's chest rather than in the air. In those moments, the universe feels close, not as an expanse of cold emptiness, but as a living, breathing presence speaking in the unspoken language of light. And yet, some who have ventured deep into the Arctic under the most powerful auroras tell of faint crackles or rustling sounds, soft snaps that seem to echo the movements above. Whether these are psychological impressions, atmospheric electricity near the ground, or simply the imagination stretching toward wonder, no one can say for certain. But perhaps that mystery is part of the beauty. The aurora reminds us that even when science explains the mechanism, awe remains. We stand on a small, frozen world under a sky painted by the breath of a distant star, watching light that began its journey millions of kilometers away transform the night into a living dream. In that moment, sound is unnecessary. The silence speaks louder than thunder, the darkness glows brighter than day, and the connection between sun and earth feels intimate and eternal. A reminder that we are part of a vast, luminous conversation written across the heavens. The sound is subtle, like the faint static that crackles through dry hair or the whisper of leaves brushed by a gentle wind. For centuries, observers described hearing delicate noises during auroral displays, soft pops, faint crackles, or quiet rustling sounds that seemed to echo the light above. For decades, scientists dismissed these claims as mere imagination, reasoning that the aurora occurs far too high in the atmosphere for any sound to travel down to Earth. Yet recent experiments have begun to challenge that certainty. Under specific conditions, charged particles can accumulate near the ground and discharge suddenly when the auroral field above shifts. These discharges, imperceptible most of the time, may create faint, crisp sounds that correspond to changes in the magnetic field overhead. If so, the air itself may act as a kind of resonant instrument, briefly translating the immense and distant energy of space into delicate terrestrial whispers. Whether these sounds are physical or psychological, born from electromagnetism or all, they remind us that wonder often transcends explanation. To stand beneath a sky alive with color and believe you can hear it breathe is to experience a connection between Earth and cosmos so intimate that silence itself seems to speak. Massive solar storms can make the aurora reach far beyond its usual Arctic home, pushing its luminous veils into tropical skies. During these extreme events, the boundaries of the auroral oval expand dramatically, carrying light deep into latitudes that rarely know its glow. Historical records tell of brilliant red and green curtains shimmering above islands, deserts, and cities near the equator, transforming familiar night skies into surreal displays. The cause lies in overwhelming surges of solar particles and magnetic disturbances that flood Earth's magnetosphere, driving energy into lower atmospheric layers. Compasses twitch, radio signals falter, and the heavens come alive with motion. To ancient eyes, such nights seem to set the entire world aflame. Even now, understanding the science does little to diminish the astonishment. The realization that Earth's invisible magnetic shield can stretch and shimmer around the whole planet is humbling. It shows that our world's connection to the sun is both fragile and vast, capable of enveloping even the warmest corners of the globe in the same luminous embrace that crowns the poles. Before science named and explained them, red auroras often provoked fear and awe. Bright crimson arcs spreading across the night were mistaken for the reflection of distant fires or omens of catastrophe. In villages across history, people would rush to warn neighbors of phantom blazes beyond the horizon, only to find the forests untouched. The color red carried deep symbolic weight: blood, war, divine anger, and chroniclers described skies that burned like furnaces, signs of cosmic unrest or divine judgment. Yet even with our modern knowledge of oxygen emissions and electron collisions, that visceral reaction remains. The sight of a red aurora still feels emotional rather than merely visual, as if the heavens themselves were expressing some unspoken feeling. This coexistence of knowledge and awe reveals an enduring truth: understanding does not destroy wonder. Instead, it deepens it, allowing reason and reverence to coexist, each enriching the other in the face of nature's grandeur. The very name aurora reflects this blend of beauty and meaning. In Roman mythology, Aurora was the goddess of dawn, the radiant herald who swept color across the sky before the sun itself rose. Her name became a perfect metaphor for the lights that brighten polar nights, a second dawn born not of sunlight but of solar wind. To ancient poets, aurora symbolized renewal and awakening, and in the same way, the aurora at the poles brings light to the darkest hours of winter, an electric sunrise from beyond the earth. When the lights unfold across the frozen Arctic sky, they echo that mythic gesture, lifting the curtain of darkness to reveal the cosmos shining gently upon the world below. Among the indigenous Sami of northern Scandinavia, the aurora is known as wahas, the light you can hear. In their traditions, the sky is alive with spirits, and the shimmering bands are thought to carry sound, a faint whisper audible only to those who stand in stillness. Speaking loudly or mocking the lights was once believed dangerous, for they might descend and carry away the disrespectful. The Sami did not merely name the phenomenon, they described a living presence, a conscious element of nature capable of responding to human behavior. To hear the light was to recognize that nature itself communicates in ways that go beyond words or instruments. Even in the age of plasma physics and spectrometers, that older wisdom persists. It reminds us that knowledge without reverence is incomplete, and that sometimes, to understand the universe, one must listen as much as observe. The colors of the aurora depend on altitude, energy, and the composition of the atmosphere. Each layer of air contributes its own hue, determined by which atoms or molecules are excited by incoming electrons. High above, where the air is thin, oxygen glows deep crimson, creating vast red veils that ripple hundreds of kilometers above the surface. Lower down, denser oxygen emits the familiar green that dominates most auroral displays. Beneath these, nitrogen molecules produce purples and blues that edge the curtains in shadowy tones, completing the celestial palette. The intensity and mixture of colors vary with the energy of the solar particles and the density of the air they encounter. Faster electrons penetrate deeper, producing brighter greens and blues. Slower ones linger higher, painting the sky with softer red arcs. In this way, the aurora becomes a living diagram of physics, a spectral fingerprint of the meeting between solar wind and planetary atmosphere, a rainbow powered not by sunlight, but by the breath of the sun itself. Though the aurora seems to drift lazily across the heavens, its motion hides astonishing speed. Each point of light is born when an atom captures an energetic electron, glows for a fraction of a second, then releases the energy as a photon before returning to rest. This process repeats millions of times per second across vast regions of the sky, creating the illusion of smooth, continuous movement. In reality, the aurora is not a single object gliding overhead but an unbroken sequence of microscopic flashes, a perpetual cycle of birth and fading so rapid that human vision merges it into a fluid dance. High-speed cameras reveal the truth. Patches blink in and out, like stars appearing and vanishing behind a translucent veil. Each glow dies almost as soon as it is born, yet together they weave an eternal, shimmering river of light that never truly stops moving. But the same energy that paints the heavens can also disrupt the tools humanity sends into space. The geomagnetic storms that drive auroras fill the upper atmosphere with torrents of charged particles capable of damaging satellites. Electronics designed for the quiet of space suddenly face bursts of radiation that flip bits in memory, short-circuit sensors, or even push spacecraft off course as the atmosphere expands with heat. Engineers must shield delicate instruments and build safeguards to survive these tempests. When storms grow intense, operators sometimes power down systems or shift orbits to protect their satellites from the storm's fury. It is a humbling reminder that the beauty above carries both wonder and warning. The same currents that inspire poets can threaten technology that sustains modern civilization. On the ground, these storms can hum through the bones of the earth itself. As magnetic fields shift, they induce vast electric currents that flow through the planet's crust and man-made structures. Power lines stretching for hundreds of kilometers act as antennas, collecting this slow-moving electricity. Transformers vibrate, their cores resonating with invisible forces, and protective systems strain to handle sudden surges. During powerful events, the overload can trip circuits and cause regional blackouts lasting hours or days. In those moments, people living beneath a brilliant aurora may hear a faint mechanical hum, the earthly echo of the magnetic storm above. It is a haunting symmetry. The same energy that fills the sky with color also stirs within the metal arteries of human technology. Beauty and vulnerability become one continuous system, linking the heavens and the ground in an intricate web of energy. To prepare for such events, satellites now act as sentinels, keeping constant watch on the sun. Orbiting observatories monitor solar flares, coronal mass ejections, and the changing winds of plasma that flow outward through the solar system. Instruments measure shifts in magnetic polarity, particle density, and velocity, translating the invisible activity of the sun into early warnings. When a solar eruption is aimed toward Earth, data races across networks within minutes, giving scientists time to forecast the storm's arrival. This watchfulness forms the backbone of space weather prediction, a modern evolution of ancient sky-watching traditions. Just as farmers once read the stars for guidance, engineers now read the sun to protect satellites, power grids, and even astronauts from harm. In all of this, the silence, the light, the sound, and the science, one truth endures: the aurora is both spectacle and story, physics and poetry intertwined. It is the visible face of invisible forces, a reminder that our small planet is part of an immense cosmic system. Whether seen from frozen tundra or tropical island, from the cockpit of a spacecraft or through the eyes of a child standing in the snow, the aurora carries the same message: that beauty and power are inseparable, that distance and connection coexist, and that even in the coldest night, the universe still finds ways to speak in light. Agencies around the world release alerts to airlines, power operators, and communication systems so they can prepare for what we now call space weather. These forecasts, once an unimaginable concept, have become a quiet safeguard for modern civilization, allowing us to anticipate solar disturbances that could once have caused widespread chaos. The satellites and probes that orbit our planet act as the first sentinels in this vast, invisible war between the Earth's magnetic shield and the charged storms of the Sun suspended within the same magnetic field they study. These watchers sense the first tremors of incoming solar waves, transforming what was once a terrifying surprise into a symphony of prediction and understanding. Thanks to their vigilance, the silent dance of auroras no longer arrives unannounced, but as a story that unfolds with science, poetry, and awe. When a solar eruption sends a coronal mass ejection careening toward Earth, it can double the size of the auroral oval overnight. These glowing rings that crown the poles expand and contract like a living pulse, their size reflecting the heartbeat of the sun's activity. Sometimes, the aurora grows so vast it spills across continents unaccustomed to such celestial displays. Entire regions, from temperate Europe to the central plains of America, suddenly find themselves bathed in ghostly green veils, as if the planet had grown a new skin of light. From orbit, satellites track these shimmering borders through ultraviolet emissions, watching them bloom and fade like phosphorescent organisms breathing in space. Every expansion offers both a spectacle and a revelation, proof that Earth's magnetic field is not a static shell but a responsive, flexible membrane that bends to the will of solar forces. It is a reminder that our planet, far from being a passive rock in space, participates actively in a cosmic dialogue, responding to solar wind and flare like a living creature reacting to touch. The auroral oval itself behaves as if it were alive. It swells outward when solar winds intensify and retreats when they subside, a slow rhythmic breathing that connects Earth's magnetosphere to the sun's changing moods. Satellite imagery captures this celestial respiration, showing the oval brighten during substorms and dim as energy disperses, much like the flare and fade of a giant cosmic heartbeat. To scientists, these cycles reveal the hidden mechanics of our magnetosphere, how charged particles circulate, how electric power flows through invisible field lines, and how our planet manages to maintain equilibrium in the midst of constant solar bombardment. To the human eye, the effect is ethereal and emotional. To watch the sky inhale light and exhale darkness is to witness Earth itself breathing. Yet the aurora does not follow the maps we know. It obeys the geometry of magnetism, not geography. If you were to draw where the lights most often appear, the glowing rings would not align with lines of latitude and longitude but with the shifting paths of Earth's magnetic poles, which wander slowly across the surface over centuries. This migration means that the best places to witness auroras also drift through time, favoring regions like northern Canada, Scandinavia, and Siberia, lands not chosen by geography but by the magnetic threads that tie them most directly to space. Those who chase the aurora learn to follow invisible maps, seeking out corridors where charged particles descend most freely, understanding that magnetism shapes our connection to the cosmos in ways compasses barely hint at. For beyond the world we navigate lies another, unseen Earth, one whose lines are drawn not in land and water but in fields of force that ripple far above the sky. The most spectacular auroras often occur at magnetic midnight, a moment different from the midnight on our clocks. Magnetic midnight is when a given region lies directly between the Sun and its magnetic pole, placing it on the planet's night side of the magnetosphere. At this time, the long magnetic tail stretching behind Earth becomes taut and charged, filled with particles waiting to surge homeward. When magnetic reconnection occurs, when those stretched lines snap and realign, rivers of electrons rush along field lines toward the poles, igniting the upper atmosphere in sudden floods of color. For those standing below, the world feels transformed. The air grows sharp, the ground still, the heavens alive with curtains of green and violet fire that ripple like breath. Around magnetic midnight, it feels as though the earth itself is perfectly positioned to receive the universe's touch, and the sky answers with its most luminous song. Twice each year, during the equinoxes of March and September, this cosmic rhythm intensifies. As Earth's tilt aligns so that its axis points either toward nor away from the Sun, the geometry between our planet and the solar wind becomes ideal for magnetic reconnection. Energy flows more freely, opening portals through which solar particles pour into our atmosphere. This pattern, known to scientists as the Russell-McFerrin effect, makes the equinox months especially rich with auroral activity. Long northern nights offer the darkness necessary for visibility, and those who travel to polar regions in these seasons often find themselves rewarded with skies ablaze in moving color. It feels as if the balance between light and dark, the symmetry of day and night, invites the cosmos to dance more brilliantly, painting twin crowns of light around both poles in a shared celebration of balance. Yet the beauty above conceals a violent truth. High in the thermosphere, more than 100 kilometers above the ground, the aurora's energy can raise temperatures to over 200,000 degrees Celsius. Here, the electrons plunging down magnetic field lines collide with atmospheric atoms at immense speeds, transferring staggering amounts of kinetic energy. And yet, if one could somehow stand there, the heat would not be felt, because there are too few air molecules to carry warmth. It is a realm where energy exists as motion, not comfort, where speed replaces sensation. Satellites passing through this region record waves of invisible heat and motion, mapping how each auroral burst reshapes the upper atmosphere. These bursts expand the air upward, increasing drag on low-orbiting spacecraft and subtly altering their trajectories. The numbers sound incredible, but they reveal how fiercely dynamic Earth's upper air becomes when struck by the sun's breath. A reminder that even the thinnest halo of gas can transform into a furnace under cosmic touch. The energy released by one brilliant aurora can equal the power consumption of a small city. Beneath that breathtaking glow lies a planetary-scale current system, transferring gigawatts of energy from the solar wind into Earth's magnetic and atmospheric systems. For a few moments, during the peak of a geomagnetic storm, the aurora may channel as much energy as a modern metropolis uses in a day, its currents flowing invisibly along field lines, lighting up the poles with the raw power of the universe. Most of that energy dissipates as heat, light, and electromagnetic waves spread across the sky. It is humbling to realize that this luminous beauty is not fragile at all. It is the visible edge of a planetary engine, a storm of electricity too immense to harness. If humanity could safely capture such energy, it would power civilization forever, but perhaps it is better that it remains untamed. Standing beneath those rippling veils, we understand that the aurora is not just light. What we glimpse as graceful color in the night sky, the ethereal greens, pinks, and violets of the aurora, is, in truth, the visible shimmer of forces that silently shape and sustain the planet's magnetosphere. These luminous veils are not small or localized phenomena. Even faint auroras cover more area than entire continents. What may appear from the ground as a fragile band of light stretching across the northern horizon is, when viewed from orbit, revealed as part of a sprawling planetary-scale structure that dwarfs the mountains, oceans, and cities below. Satellite imagery shows vast sheets of brightness spanning hundreds to thousands of kilometers, arching effortlessly over landscapes, wrapping around the poles in a continuous ring known as the auroral oval. Even when the sun's activity is calm and space weather appears quiet, this glowing ring persists, encircling polar regions in patterns larger than North America. The human eye perceives the aurora as a local and fleeting spectacle, but in truth, it is immense, continuous, and intricately connected to the flow of energy between Earth and the Sun. It is an atmosphere-wide performance unfolding above countless observers at once, binding distant places together beneath one luminous canopy. The northern lights are not confined by geography or borders. They are a global connection written in motion and energy, linking nations beneath a single sky. Pilots traversing the Arctic and subarctic skies sometimes glimpse the aurora from their cockpit windows, floating like luminous mist just above the troposphere. High-altitude flights bring them close to the lower edges of the auroral display, where ribbons of green and violet ripple at eye level, appearing so near that one might imagine reaching out and touching them. During these moments, cabin lights are sometimes dimmed so passengers can witness the spectacle in full, and even those unable to see directly notice a faint green shimmer dancing across the aircraft wings. It is an encounter that feels almost supernatural, a meeting between human invention and a cosmic process older than civilization itself. For pilots, the aurora is both a breathtaking wonder and a quiet reminder that they are flying not only through air but through the dynamic weather of space. In the quiet hum of engines far above the sleeping world, the aurora becomes a silent companion, a shared dance between human technology and the forces that shaped our planet long before flight existed. Satellites have recorded auroras so bright they rival the full moon. During intense geomagnetic storms, the upper atmosphere glows with such concentrated energy that it illuminates the night like a ghostly daylight. Instruments aboard Earth-observing satellites capture these phenomena in ultraviolet and visible wavelengths, revealing peaks of brightness far beyond the limits of human sight. From orbit, the polar regions appear as halos of emerald and crimson fire, radiant enough to cast light upon distant clouds and icy surfaces thousands of kilometers away. These extraordinary displays occur when immense electric currents surge into the ionosphere, saturating the upper atmosphere with charged particles descending along magnetic field lines. For those standing on snow-covered ground beneath the glow, the brightness is surreal. The snow gleams, the air feels charged, and shadows appear where none should exist in the middle of the night. The boundary between day and night seems to blur, as if the world itself were suspended between two realities. For scientists, these moments offer valuable insights into how Earth interacts with the Sun at its most extreme, when beauty and power converge in measurable brilliance. Yet, the same storms that paint the sky in light can endanger those who travel beyond the safety of Earth's magnetic field. When solar eruptions hurl high-energy particles into space, Earth's magnetic shield captures most of them, channeling the rest toward the poles where they create the aurora. But astronauts in orbit, especially those venturing beyond the magnetosphere, face these charged particles directly. Radiation levels can rise dangerously high during such events, posing threats not only to human health but also to the delicate electronics that sustain life in space. Space agencies around the world continuously monitor the Sun's activity, ready to alert crews aboard the International Space Station to move into shielded compartments when a solar storm approaches. For those astronauts, witnessing the aurora from above is both breathtaking and sobering. From their vantage point, they see the glowing rings below marking the invisible boundary that protects life on Earth, a reminder that every arc of color is also a sign of the storm's ferocity, an electric warning painted in beauty. What those on the ground see as art in the heavens, those in orbit know as energy strong enough to harm. The aurora is not merely a light show but the visible edge of an immense, invisible structure, Earth's magnetosphere. This magnetic bubble surrounds our planet like a vast, living shield, sculpted continuously by the solar wind, a stream of charged particles flowing outward from the Sun. The magnetosphere deflects most of these particles, diverting them around Earth while allowing a fraction to slip through near the poles, where magnetic field lines open towards space. Inside this region, plasma, radiation, and electromagnetic waves swirl in a ceaseless dance of pressure and flow. It is here, within this magnetic cocoon, that storms form and energy from the solar wind becomes trapped, building tension until it bursts forth in the spectacle we see as the aurora. Without this protective bubble, the Sun's relentless wind would strip Earth's atmosphere over time, leaving the planet barren and exposed like Mars. The aurora, beautiful and ephemeral, is thus not a mere curiosity. It is the luminous signature of our planet's ongoing defense against the raw forces of space. On the sunward side, the magnetosphere is compressed by the pressure of the solar wind, while on the night side, it is stretched outward into a long magnetic tail, or magnetotail, that extends millions of kilometers into space, so long it sometimes reaches beyond the moon's orbit. This tail is where much of the drama unfolds. As solar wind flows past Earth, it drags the magnetic field into tension, twisting and storing vast amounts of energy. when the tension becomes too great, magnetic field lines reconnect in a sudden release of power, flinging charged particles back toward Earth's poles in brilliant waves that ignite the night sky. Spacecraft passing through this region detect surges of plasma and sudden flips in magnetic orientation, like tremors in an invisible ocean. In this way, the aurora we see is only the visible end of a cosmic chain reaction, a bright echo of distant turbulence taking place far down the planet's magnetic tail. When the solar wind intensifies, the magnetotail tightens like a drawn bowstring, humming with potential energy that soon releases in bursts called substorms. These magnetic reconnection events occur deep in the stretched tail, where field lines twisted by solar winds suddenly snap and realign. In moments, pent-up energy races back toward Earth along magnetic conduits, flooding the polar atmosphere with electrons and igniting the aurora in a sudden surge of motion and light. To the eye, a quiet, faint aurora suddenly flares, its gentle arcs transforming into curtains that ripple, twist, and leap across the entire horizon. The once calm sky erupts in wild motion, ribbons of color curl and split, shimmering with chaotic grace as though the atmosphere itself had come alive. Within minutes, the scene can shift from serenity to frenzy, and the ground below glows faintly with reflected green light. Each substorm lasts only a short while before fading into calm again, but in those moments the world feels profoundly alive, as if Earth and Sun were exchanging another electric breath in their endless cosmic conversation. Scientists use arrays of cameras, magnetometers, and satellites to trace the timing and structure of these substorms, revealing that they unfold in intricate waves rather than a single explosive event. Each ripple of light corresponds to subtle rearrangements of the magnetic field, propagating through the ionosphere like chords in a symphony of energy. What looks fluid and continuous to the human eye is, in fact, a tapestry woven from countless magnetic variations measured in fractions of a nanotesla. Even the tiniest fluctuations in these fields shape where electrons descend, how the colors form, and how light ripples across the sky. Sensitive instruments detect these micro-tremors as the aurora shimmers, proving that immense beauty can emerge from infinitesimal causes. The aurora is, at its heart, magnetism made visible, a portrait of unseen forces dancing across the heavens, connecting the physics of the cosmos to the wonder of human perception. It is a phenomenon that humbles science and inspires art, reminding us that every color we see is a translation of energy, every movement a dialogue between Earth and the stars, and every quiet night beneath its glow a moment shared with the universe itself. The aurora is one of nature's most captivating displays, a phenomenon where chaos becomes graceful and invisible magnetic forces are painted across the sky in waves of color and motion. Each ripple moves like wind over water, a visible signature of turbulence and plasma, and the charged particles that drift along unseen pathways shaped by magnetic fields. To scientists, the aurora is not just beauty but information, a living map of magnetic change that reveals how cosmic forces interact. The delicate folds of light are not random artistry. They are the handwriting of physics, where grandeur arises from precision, and what looks like ethereal beauty is the visible architecture of the universe's laws and motion. On Jupiter, these same processes unfold on a scale beyond imagination. Jupiter's auroras are thousands of times more powerful than Earth's, driven by a magnetic field so vast it would stretch wider than the Sun itself. Charged particles crashing into the planet's atmosphere produce blazing ovals of ultraviolet light that never fade, burning perpetually both day and night. Unlike Earth's transient auroras, Jupiter's are fueled not only by the solar wind but also by the planet's own rapid rotation, which constantly stirs its magnetic field. Spacecraft such as Juno have captured breathtaking images of these colossal polar crowns, glowing like electric halos, each one a manifestation of magnetism at its most intense. These luminous storms remind us that what we see as fleeting on Earth can become eternal on other worlds, a roaring blaze that lights the gas giant's poles with cosmic fire. Jupiter's volcanic moon Io contributes directly to this spectacle. Constant volcanic eruptions release sulfur and oxygen into space, forming an enormous torus of charged gas around the planet. Jupiter's magnetic field captures this material, accelerates it, and hurls it toward the atmosphere, where it strikes and forms glowing footprints within the larger auroral ring. Io acts almost like a generator, connected to Jupiter by immense currents that flow along magnetic field lines, transferring millions of amperes of electricity. It is a duet of energy and beauty, a magnetic bond between planet and moon that stretches across hundreds of thousands of kilometers, linking two worlds in a symphony of light. Saturn's auroras, by contrast, glow in deep shades of blue and pulse with radio waves, more subtle and harmonious. Its perfectly aligned magnetic field produces symmetric, elegant circles of light that ripple through its hydrogen-rich atmosphere when struck by solar winds. Instruments aboard spacecraft detect simultaneous bursts of radio emissions, rhythmic and regular, allowing scientists to measure the true length of Saturn's day. The auroras shimmer like thin rings of fire on the dark side of the planet, delicate to the eye but vast in origin, shaped by the same immense magnetic storms that drive the planet's upper atmosphere. These displays form an invisible symphony of light and sound, a performance that can only be heard through radio waves in space, where the boundaries of sound and color blur. Uranus and Neptune, however, twist the concept entirely. Their magnetic fields are wildly tilted and offset from their rotation axes, producing auroras that wander unpredictably across their skies. These tilted, shifting fields create chaotic, asymmetrical glows that defy the neat polar rings seen on other planets. Each rotation reshapes the pattern, and each solar gust stirs a new arrangement of arcs and flares. Observations by Voyager and Earth-based telescopes reveal that their auroras appear in different places each time, a reminder that beauty can spring from disorder. Their magnetic fields act like cosmic kaleidoscopes, twisting charged particles into ever-changing paths, creating fleeting, shifting light shows that challenge our understanding of magnetism and planetary structure. Even the dim, failed stars known as brown dwarfs join this celestial performance. Existing between the definitions of star and planet, brown dwarfs were once thought to be dark, cold bodies, but radio telescopes have revealed bursts of emission identical to auroral activity. These substellar objects, with magnetic fields hundreds of times stronger than Earth's, glow faintly where plasma interacts with their atmospheres. Some even pulse with regularity, suggesting rotating auroral ovals similar to those seen on Jupiter. In certain cases, the power release rivals that of a stellar flare, proof that even these dim worlds can shine with the same magnetic vitality that animates planets and stars alike. The discovery of auroras on brown dwarfs has blurred the line between planetary and stellar physics, showing that magnetism is a universal language spoken throughout the cosmos. Each aurora, no matter its source, is the visible endpoint of an electric circuit linking a planet to its star. The shimmering beams we see are conduits through which charged particles flow, carrying information about the magnetic relationship between a world and its environment. Scientists study these lights not only for their beauty but to decode their messages, reading the strength, shape, and orientation of magnetic fields across unimaginable distances. Beyond our solar system, this knowledge helps astronomers imagine how exoplanets interact with their suns, how magnetism shapes their climates, and even how it might shield them from radiation. Thus, the aurora becomes both a spectacle and a scientific instrument, a diagnostic tool that speaks in color, pulse, and rhythm. Every glowing curtain of light on Earth, every blazing crown on Jupiter, every radio pulse from Saturn, is part of a single, grand story of energy flow and magnetic connection. The aurora reminds us that the universe is bound together by invisible forces that can sometimes be seen. On Earth, our own auroras are mirrors of this cosmic conversation. What we witness from frozen lakesides and mountain ridges, those curtains of green, violet, and red light shimmering across the night sky, are the visible fingerprints of our planet's interaction with the sun's satellites orbiting above. Record these same events as waves of data, but to the human eye they appear as living art. Each filament corresponds to a current, each flicker to an exchange of energy between our world and the solar wind. The aurora becomes both phenomenon and language, a translation of the sun's invisible breath into something we can perceive and feel. Through it, we can literally see the boundaries of our magnetosphere flex and breathe, revealing how our planet's invisible shield bends under pressure and recovers, resilient yet fragile. To stand beneath an aurora is to witness the living geometry of Earth's relationship with the cosmos, a living dialogue of color and motion between our magnetic field and the energy of the star that sustains us. and within that dialogue are many variations. Proton auroras, for instance, differ from the more familiar displays caused by electrons. When heavier protons descend along magnetic field lines and collide with atmospheric gases, they produce soft, diffuse red glows that spread quietly across the sky rather than dance in vivid curtains. These are the subtle blushes of the heavens, gentle reminders that even the faintest displays are part of the same story, a story of constant energy exchange, of matter and magnetism intertwined. The aurora, in all its forms, tells us that our universe is alive with motion, connection, and conversation. It is the voice of physics rendered visible, proof that we live in a cosmos where even the emptiness between worlds hums with electric life. To gaze upon it is to see not just beauty, but the very heartbeat of the universe itself. Proton auroras, often invisible to the human eye, are studied using instruments sensitive to ultraviolet light because their faint glow forms high above Earth, where the air is too thin for rapid collisions. The red light from these subtle displays lingers, revealing a quiet layer of our planet's interaction with the solar wind. Though they lack the drama of green or purple auroras, proton auroras remind us that even the faintest forms of light have meaning, each shaped by a different kind of traveler from the sun. Sometimes, however, the aurora behaves in ways that seem almost supernatural. Within a curtain of color, dark lanes appear, shapes that seem to erase the light itself. These are known as black auroras, mysterious voids moving across the sky like rivers of night flowing through brightness. They are not shadows but regions where electric fields prevent charged particles from reaching the atmosphere, creating zones of darkness in the middle of glowing air. As scientists observe these ghostly forms, they realize that black auroras reveal how energy redistributes during the final stages of a geomagnetic storm. They form where the magnetosphere begins to relax after violent turmoil, tracing invisible boundaries between energy and calm. To the human eye, they are mesmerizing and eerie, proof that darkness can move with the same grace as light, and that even in illumination there are spaces where energy pauses to breathe. Then there is Steve, a mysterious purple streak unlike any typical aurora. First noticed by amateur photographers across Canada and Northern Europe, Steve appeared as a narrow violet band stretching across the sky, often far south of the usual auroral zones. At first, it was mistaken for a normal aurora, but data revealed something entirely different. Steve, short for strong thermal emission velocity enhancement, is caused not by collisions between particles but by a stream of hot plasma racing through the upper atmosphere. The air itself glows as it heats to extraordinary temperatures, producing a color unlike any other, a soft magenta or mauve that cuts across continents in a nearly perfect line lasting up to an hour. The discovery of Steve changed our understanding of Earth's magnetic system, proving that the skies still hold surprises even in an age of satellites and constant observation. It forms far south of traditional auroral zones, where plasma flows along magnetic field lines, heating the air through friction as it meets cooler layers. Satellites have measured temperatures above 3,000 degrees Celsius within this narrow band. Steve's appearance above cities that rarely see auroras shows how dynamic and flexible Earth's magnetic boundaries truly are. It was discovered through the collaboration between citizen scientists and professionals, people comparing photographs, noticing patterns, and turning curiosity into discovery. Steve reminds us that science often begins with wonder, and that our planet's interaction with space is more complex than once thought. Beneath Steve, another phenomenon sometimes appears: the green picket fence, rows of narrow green columns flickering in rapid sequence like glowing torches beneath the purple band. This formation occurs when waves of energy from the upper plasma flow interact with oxygen atoms at lower altitudes. Each column brightens and fades in rhythm, creating a fast-moving dance of emerald light. High-speed cameras reveal that these lights respond to invisible forces above them, forming a synchronized display that links multiple atmospheric layers. The green picket fence is a rare glimpse into how energy travels vertically through the sky, showing that Earth's atmosphere and magnetosphere are deeply connected, reacting together to the electric music of a geomagnetic storm. The aurora's influence reaches far beyond what the eye can see. The same charged particles that paint the night sky with color also generate bursts of radio energy that travel through space. Spacecraft detect these signals as eerie whistles and chirps, electromagnetic waves created by electrons spiraling along magnetic field lines. These radio emissions are not just noise, they carry valuable information about how energy moves between Earth and the Sun. The patterns of pitch and rhythm within them encode details about the magnetic environment. Some spacecraft detect these sounds long before the aurora becomes visible, offering early warnings of approaching space storms. It is as if the sky sings before it glows, sending its invisible notes through the vacuum of space. By listening to these signals, scientists can map the shape and motion of Earth's magnetic field. Multiple satellites and ground stations combine their data to form a moving picture of the planet's magnetic architecture, how field lines bend, reconnect, and shift during storms. This music of magnetism helps improve space weather forecasts, protecting satellites and power grids from disruption. Though inaudible to human ears, these radio voices tell the same story as the auroral lights, beauty and information intertwined, light and sound emerging from the same cosmic dance. The visible and the invisible are one continuous symphony, the glowing arcs in the sky and the whispers of radio waves both speaking of the same vast energy flow. Among the many variations of the aurora, pulsating auroras are especially hypnotic. Instead of drifting smoothly, they flash in rhythmic beats, blinking on and off like a living pulse. These patches of light often appear after magnetic substorms, their timing controlled by waves traveling through the magnetosphere. The pulses can be steady or erratic, lasting seconds or hours, and sometimes seem almost alive, like the sky itself breathing. To observers on the ground, this rhythmic flickering feels peaceful and surreal, a reminder that the planet itself moves to invisible cosmic rhythms. Scientists studying them have discovered that these flickers are guided by electromagnetic waves that modulate the flow of electrons into the atmosphere, regulating when and where they strike. The pulsating aurora thus becomes a bridge between motion and music, between what we see and what we sense, a heartbeat of Earth rendered in light. Among the rarest and most majestic forms are the omega auroras, great luminous arches that resemble the Greek letter omega floating above the horizon. They form when powerful electric currents bend magnetic field lines into looping structures that reconnect beneath themselves, creating immense bridges of light that can stretch hundreds of kilometers across the sky. These glowing waves drift slowly, shifting shape as magnetic tension changes. To scientists, omega auroras mark boundaries where plasma flows collide and reorganize, creating temporary yet perfectly symmetrical structures. To those who witness them, they seem almost solid, celestial gateways or crowns made of living light, rising, stretching, and dissolving in serene silence. Their brief existence feels like the universe revealing a hidden order, a fleeting architecture built from energy itself. All these varieties, proton auroras, black auroras, Steve, the green picket fence, pulsating lights, and omega waves, together tell a single story of connection. They show that the aurora is not merely a spectacle but a living system, the visible expression of how our planet breathes, responds, and communicates with the sun. Every flicker and ripple in the sky is a message from space, a signal of electric dialogue between the Earth and the star that sustains it. The aurora transforms invisible physics into visible poetry, turning energy and magnetism into something we can see and feel. It reminds us that our world is not isolated but part of a vast electromagnetic web, constantly shaped by the cosmic forces around it. To stand beneath such light is to witness the universe writing its story across the heavens, a story of power and beauty, of silence and motion, of a planet forever in conversation with the sun. Omega auroras show how order can emerge from turbulence, how even the most chaotic forces in space can find balance long enough to sketch beauty upon the dark canvas of night. The aurora, far from being a mere spectacle of light, is a phenomenon that intertwines the heavens and earth in an intricate dance of energy. When geomagnetic storms release energy into the upper atmosphere, they trigger not only glowing colors but also waves of motion that ripple across the planet. These atmospheric gravity waves, invisible to the human eye, move across entire continents, altering winds and temperature patterns thousands of kilometers away from the poles. Scientists, through satellites and weather balloons, detect faint oscillations in pressure and density, revealing how these ripples link space weather to our planet's climate system. Each flare of light sends a tremor through the air we breathe, showing that the aurora is both a vision of beauty and a driver of atmospheric motion. Even as the light fades, the energy lingers, its effects rippling quietly through layers of air and plasma that form Earth's protective shell. When solar particles stream toward the poles, they collide with atoms in the thin upper atmosphere, pouring vast amounts of energy into those fragile layers and causing them to expand outward. This invisible swelling, detected by satellites in orbit, shows the atmosphere rising higher than usual, an unseen tide reaching toward space. The expansion alters how gases mix, how radio waves travel, and even how the boundaries of our planet shift, turning each auroral display into both a scientific event and a physical transformation of Earth itself. The atmosphere, heated and stirred by solar energy, breathes in response, swelling and contracting in tune with storms millions of miles away on the surface of the Sun. This expansion, however, is not without consequence. Satellites that usually orbit through near-vacuum conditions suddenly encounter resistance from the denser air. The drag slows them down, altering their paths, and during intense geomagnetic storms, entire groups of satellites can be lost before operators have time to react. Space agencies monitor these changes carefully, using thrusters to correct orbits and preserve stability. The same invisible currents that paint the poles with shimmering color can therefore reach into the heights of low Earth orbit, tugging gently on machines built by human hands. It is a humbling reminder that even our most advanced technology must move in rhythm with the cosmic breathing of the Earth and the Sun. Beneath the visible glow, streams of charged particles flow along magnetic field lines, connecting space and Earth in immense electric circuits. These auroral currents, cosmic wires stretching between the poles and the magnetosphere, carry energy with precise balance. When they strike atoms in the atmosphere, collisions release light, completing an electrical circuit that spans the sky. Instruments aboard satellites detect strong variations in magnetic strength as these currents flow, while ground-based sensors record the same energy coursing silently beneath our feet. This natural power grid, operating on a planetary scale, moves vast quantities of energy with elegance that defies imagination. The magnetic connection between the Sun and Earth transforms invisible motion into one of the most breathtaking sights ever witnessed, the dancing aurora. But these same currents can reach much farther than the sky. During strong geomagnetic storms, electric energy travels through the ground, inducing secondary currents in long metal structures such as pipelines and railways. These conductive systems act like giant antennas, absorbing and carrying energy across great distances. Engineers have measured voltages strong enough to interfere with sensors, corrode pipelines, and disrupt communication equipment. In extreme cases, electrical systems can experience overloads or false readings as the Earth's surface becomes an unwitting conductor of cosmic electricity. Although modern infrastructure is grounded and protected against such disturbances, the phenomenon remains a vivid reminder that the aurora's reach extends deep into the fabric of civilization. The lights above and the electricity below are two sides of the same process, an exchange of power between sky and soil. In the 19th century, when telegraph lines stretched across continents, operators witnessed this power firsthand. During powerful auroral storms, they reported their wires buzzing with unseen energy, needles twitching without any human signal, and sparks leaping between contacts. Some even discovered that, after disconnecting their batteries, they could still send short messages powered entirely by the aurora itself. The sky had become part of their network, the Earth's magnetic pulse turning copper lines into instruments of nature's communication. One of the most dramatic examples came in 1859, when the great geomagnetic storm known as the Carrington event struck the planet. Auroras illuminated the night sky as far south as the Caribbean, while telegraph offices across Europe and America burst with surges of electricity. Lines sparked, papers caught fire, and operators worked in astonishment as messages continued to transmit with no power source at all. Scientists later realized that a massive ejection of plasma from the Sun had collided with Earth's magnetic field, flooding it with energy and revealing the immense connection between solar activity and life on Earth. The Carrington event remains a defining reminder that beauty and danger often share the same source. If such a storm were to occur today, the effects would be far more devastating. Modern technology is much more sensitive than 19th century telegraphs. Satellites could be damaged by radiation, GPS systems could falter, and communication networks might collapse under the onslaught of electromagnetic energy. Power grids, linked by vast transmission lines, are especially vulnerable. The slow-moving geomagnetically induced currents that arise during such storms can overload transformers and cause widespread blackouts lasting days or even weeks. Airplanes might need to reroute to avoid high-latitude interference, and global internet traffic could be disrupted. In anticipation of such risks, scientists around the world now monitor the sun continuously, using satellites to track solar flares, coronal mass ejections, and other signs of impending geomagnetic storms. Early warning systems offer precious hours to disconnect sensitive circuits, shield satellites, or adjust flight paths. Yet even with all our preparation, a Carrington-level event would still challenge humanity's technological resilience, reminding us how delicately balanced our civilization is between innovation and the forces of nature. Auroras, for all their diversity, occur most frequently where Earth's magnetic field is strongest, near the poles. But their influence radiates across the globe, connecting Earth's upper atmosphere, magnetosphere, and even human society into one vast system. In their flickering beauty lies evidence of physics at play: electric currents, plasma flows, magnetic reconnection, and the constant exchange of energy between the Earth and the Sun. Each variation of aurora, from green curtains to red arcs, from violet bands like Steve to pulsating lights that blink in rhythm, reveals a different aspect of this universal interaction. They are scientific marvels, aesthetic wonders, and subtle teachers all at once. To study them is to study balance in chaos, order in turbulence, and harmony in motion. The aurora shows that every burst of light above the horizon has consequences below it, linking our planet to the vast machinery of the solar system. It is both the Earth's shield and its storyteller, an ancient, glowing language written across the sky by the breath of the universe itself. The magnetic field of Earth acts as a grand funnel, channeling charged solar particles along invisible lines of force toward the planet's poles, where these streams of energy converge in luminous displays known as auroras. These polar regions, where the magnetic field lines intersect and focus most sharply, become natural theaters of light and motion. Here, energy from the sun finds its way into the upper atmosphere, colliding with atoms of oxygen and nitrogen and transforming invisible radiation into brilliant color. These regions of greatest concentration are called the auroral ovals, broad, ring-shaped zones encircling each magnetic pole. They drift slowly as the magnetic poles shift over centuries, yet they remain near the frozen extremes of the Earth, where the night lingers long enough for the heavens to burn. Within these ovals, the lights appear not as rare events but as rhythmic visitors, often several times each week during geomagnetically active periods. The brightness, height, and clarity of the aurora vary depending on the strength of Earth's magnetic field at that location. When the field is stronger, the curtains of light sharpen into clear, distinct forms. When it weakens, the colors diffuse, smearing gently across the sky. Thus, every flicker of light over the poles tells a story of the sun's activity and the planet's magnetic heartbeat, a visual measure of the deep connection between our world and its star. In northern lands like Alaska, Norway, Finland, and Canada, the aurora is a constant companion through the long winter months. Children grow up with its glow as a familiar presence, learning to recognize subtle cues in the cold, clear air that suggests the lights will return that night. Travelers from around the world venture northward to see this cosmic dance firsthand, hoping to witness what locals often describe as both ordinary and miraculous. In these regions, the aurora shapes daily life and culture alike. It is painted on souvenirs, sung about in folk songs, and studied in research stations perched beneath the magnetic oval. Scientists deploy magnetometers, cameras, and satellite links to monitor the shifting bands of energy in real time, while artists and poets find inspiration in the same veils of light. Each display is unique. Sometimes it appears as a faint silver-green arc trembling on the horizon, other times as a furious storm of color cascading from zenith to edge. To those who live beneath its glow, the aurora is more than light. It is rhythm, ritual, and revelation, a bridge between natural beauty and scientific inquiry. While the northern lights have long been celebrated, their southern counterpart, the aurora australis, burns just as brightly over Antarctica, though it is rarely seen by human eyes. The southern magnetic field is slightly more compact and powerful, allowing particles to penetrate deeper into the atmosphere and ignite colors of remarkable intensity. On the icy plateaus of the South Pole, when clouds and blizzards briefly relent, the entire sky can turn into a shifting canvas of green, crimson, and violet. Researchers stationed at isolated Antarctic bases describe the experience as both humbling and transcendent, a silent orchestra of light conducted by the sun itself. Yet most of these southern performances remain hidden behind layers of snow and storm, seen only by satellites orbiting high above. From space, instruments capture the full brilliance of the aurora's circular flow, proving that beauty can exist magnificently even without witnesses. The southern lights remind us that the universe does not need eyes to shine. Its art is self-sufficient, painted across the poles whether or not anyone looks up to see it. Even when the world below is bathed in daylight, auroral activity continues, unseen but not absent. Daytime auroras occur in ultraviolet wavelengths, invisible to human eyes but easily detected by specialized instruments. These displays, hidden beneath the bright blue of the noonday sky, pulse and ripple just like their nighttime counterparts. Charged solar particles continue to collide with the rarefied gases near the poles, transferring energy in patterns that can extend across thousands of kilometers. What appears to us as an empty, sunlit sky over tundra or sea ice is, in reality, a stage alive with movement and glow beyond our perception. From space, satellites equipped with ultraviolet sensors observe these hidden auroras continuously, tracing the outlines of the auroral ovals even in full daylight. The vantage from orbit allows an uninterrupted view, free from clouds, air scattering, or weather interference. In these observations, scientists can watch energy flow into Earth's atmosphere in real time, mapping how storms evolve hour by hour. They combine this data with particle counts, magnetic field measurements, and solar wind readings to understand how the planet responds to the sun's moods. Through such studies, invisibility becomes information, and the unseen becomes understood. Even when no human gaze can witness it, the aurora continues to write its luminous script upon the sky, while satellites serve as its attentive pen. The human effort to capture and study the aurora began long before the space age. In the 19th century, patient photographers braved freezing nights to record the lights using fragile glass plates coated in slow-reacting chemicals. Exposure time stretched into minutes or even hours, during which a single gust of wind could ruin the image. They had to track the stars carefully to compensate for Earth's rotation and protect their cameras from frost. Despite these challenges, the earliest photographs revealed arcs and veils exactly as described in scientific journals, confirming the accuracy of earlier hand-drawn sketches. Each image became a fusion of art and evidence, a still moment from a sky in perpetual motion. These pioneers turned wonder into data, helping transform auroral observation into a precise scientific discipline. Through their lenses, humanity began to measure height, curvature, and change, comparing patterns across years and building the foundations of space weather research. Their work preserved ephemeral light in physical form, allowing generations to study what vanishes within seconds in nature. Today, modern cameras and digital sensors extend that legacy, revealing colors invisible to human vision. Our eyes, limited in the dark, perceive mainly shades of green, the hue produced when solar particles strike oxygen atoms around 100 kilometers above Earth. But digital instruments can collect light across the full visible spectrum and beyond, exposing faint blues, purples, and reds that the human retina cannot register. With fast lenses and long exposures, photographers bring out delicate gradients and overlapping structures that tell stories of altitude and atomic interaction. The images they produce are not exaggerations but translations, accurate representations of wavelengths that lie beyond biological perception. When these photographs are compressed into time-lapse sequences, the aurora's movement becomes even clearer, revealing waves, spirals, and rhythmic pulses that help scientists decode the flow of energy through the ionosphere. In this way, The camera becomes both an artistic and analytical tool, bridging the gap between what we feel and what truly exists. The colors themselves carry meaning. Each shade in the auroral spectrum arises from specific atomic reactions triggered by collisions between solar particles and atmospheric gases. Oxygen at high altitudes produces crimson or deep red light when excited by slower electrons, while oxygen lower down emits the familiar bright green when struck by faster-moving particles. Nitrogen, when energized, glows purple or blue, especially along fast-moving edges of auroral curtains where collisions occur in rapid succession. The tempo of these reactions determines the balance of colors we see. As geomagnetic storms strengthen, energy levels shift, and the palette changes accordingly. A trained observer can read the sky almost like a code, inferring altitude, density, and energy from the hues and shapes that appear. Each burst of red or flicker of violet tells of electrons dancing through magnetic fields at specific speeds, of invisible exchanges of power made visible through light. The sky becomes a living spectrum, its colors whispering data about space itself. Auroras vary dramatically in shape as well as color. On calm nights, they may appear as a single arc stretching silently across the northern horizon, faint and steady like a painted line of mist. When solar activity intensifies, that arc unfurls into massive curtains of light that ripple across the sky, folding and pleating as though stirred by an unseen wind. These structures mirror the geometry of Earth's magnetic field lines, tracing invisible energy paths through the ionosphere. To an observer on the ground, the effect is mesmerizing, walls of light rising and swaying, stars appearing and vanishing behind them, distant mountains glowing under waves of green fire. Pilots flying at high altitudes see these same forms from above, while astronauts aboard the International Space Station look down upon vast rings of shifting radiance that encircle the poles. Every aurora, whether a gentle veil or a roaring storm, reveals the same underlying physics, the meeting of solar energy and Earth's magnetism. The arc is a border, the curtain, a flood. Together they tell the story of a living planet continually brushed by the breath of its star. And so, from the dark tundras of the north to the silent glaciers of the south, from the visible brilliance of night to the hidden glow of day, the aurora remains one of nature's most profound expressions of connection. It binds Earth to the sun, science to art, and human curiosity to cosmic motion. It is at once a phenomenon and a metaphor, proof that even in the most chaotic exchange of forces, beauty can arise, symmetry can form, and meaning can shine through. The aurora does not belong only to those who see it, it belongs to the planet itself, a luminous pulse that has flickered above our world for billions of years and will continue long after our lights below have faded. The aurora, one of Earth's most breathtaking natural phenomena, is not merely a display of color and light but a living story of physics, magnetism, and cosmic connection unfolding high above our heads. When one stands near the center of the auroral oval during a strong display and looks straight upward, the sky can transform into a luminous crown of radiance. Rays of light seem to shoot outward in every direction, converging into a starburst that gives the impression that the heavens themselves have opened into a glowing flower. This remarkable crown, often called a corona, appears when an observer stands directly beneath a region where magnetic field lines point nearly straight downward, causing the long vertical rays to be visually compressed into a radiant hub. To those who witness it, the effect feels as if the aurora is descending upon them rather than drifting sideways across the sky. The crown is both a triumph of perspective and a revelation of geometry, a moment when human position and cosmic structure align. Photographs can preserve its radial symmetry, but even the finest image cannot capture the living motion of the rays as they flicker, pulse, and seem to breathe. The corona is not an alteration in the aurora itself, but a shift in how it is perceived, an illusion born from perfect alignment between magnetic direction and human gaze. If one moves only a short distance across the snow, the radiant crown dissolves back into wide, parallel curtains, revealing the dependence of the spectacle on a precise vantage point. Many experienced observers seek this alignment intentionally, walking under broad arcs until the pattern suddenly snaps into focus, creating the feeling of stepping through an invisible doorway into another realm. This experience teaches an important truth, that the aurora's beauty is three-dimensional, alive with depth and structure invisible from any single perspective. The most dramatic formations are not always the most powerful, but often the most perfectly aligned. Auroras do not always begin as grand, sweeping arcs. Often they first appear as small, quiet patches of light scattered across the sky, faint and hesitant, like the early notes of a song waiting to begin. These patches brighten and fade without moving much, as if testing the atmosphere for permission to grow. Instruments placed across the polar regions record tiny disturbances in electric currents during these moments, signs that energy is building within Earth's magnetic field. Slowly, the scattered patches link together into short segments, then into a loose arc that stretches and stabilizes. This subtle transformation, known to scientists as the growth phase, is the prelude to the storm, a period of preparation when invisible forces organize themselves into visible form. It may last from a few minutes to over an hour, as the magnetosphere, the region surrounding Earth controlled by its magnetic field, stores energy from the solar wind. Magnetic lines stretching behind the planet in the long tail of Earth's field become taut, like rubber bands pulled to their limit. Deep within the ionosphere, currents strengthen in anticipation of release. When the stress becomes too great, a process known as magnetic reconnection snaps the distant field lines, flinging charged particles down toward the poles at tremendous speed. This sudden release begins the expansion phase, the dramatic heart of an auroral substorm. What was once a quiet arc explodes into motion. Curtains of green and violet surge across the entire sky, twisting and folding like waves in an invisible ocean. The upper atmosphere becomes a living canvas, each stroke painted by electrons colliding with atoms of oxygen and nitrogen. Satellites orbiting far above detect enormous changes in current flow, and instruments on the ground record magnetic fluctuations so strong they can trigger alarms in scientific observatories. To those watching from below, the world feels electrified, the air sharp, alive, and vibrant. This is the aurora's heartbeat made visible, the Earth itself exhaling the energy it gathered from the sun. The sky pulses with motion too grand to fully comprehend, and in those moments the boundary between planet and cosmos seems to vanish. Eventually, the spectacle begins to fade. As the magnetosphere relaxes and its tension unwinds, the recovery phase begins. Electric currents weaken, the shimmering curtains grow dim, and what once danced with fierce intensity now lingers as soft arches before fading completely. Yet, even as the light disappears, its echoes remain in space. Waves of plasma ripple outward through the magnetosphere, carrying the memory of the storm into the solar wind. Scientists describe this process as the system's way of returning to equilibrium, like a stretched cord slowly coming back to rest. On the ground, the change feels peaceful, almost sacred. The last faint whisper of green dissolves into darkness, leaving behind silence and awe. But the aurora's influence does not end with beauty. It is also a participant in Earth's atmospheric chemistry. Every burst of charged particles that collides with our atmosphere initiates subtle reactions that alter the air's composition. In the thin upper layers, far above where clouds form, these collisions break apart molecules and create reactive compounds such as nitric oxide and hydrogen oxide. These gases drift slowly downward over days or weeks, affecting the chemistry of layers far below. Nitric oxide, in particular, plays a role in regulating ozone, the fragile shield that protects life from harmful ultraviolet radiation. When geomagnetic storms are strong, large quantities of these reactive gases form, temporarily changing how much radiation the atmosphere absorbs and emits. Though the effect is small compared to human influences, it demonstrates a profound truth: what happens at the edge of space can subtly influence the climate of the world below. Satellites orbiting Earth track these changes, capturing infrared signatures and chemical fingerprints that reveal how auroral events ripple through the entire atmospheric system. One of the most fascinating discoveries of recent decades is how auroral energy creates nitric oxide that travels downward, interacting with the ozone layer. When high-energy electrons from the magnetosphere strike oxygen and nitrogen atoms, they break them apart and allow them to recombine into nitric oxide. Over time, this gas descends to the stratosphere, where it reacts with ozone molecules, converting some of them back into ordinary oxygen. This process temporarily reduces ozone concentration in small regions. Researchers have followed this chain reaction using satellites capable of detecting minute chemical traces, confirming that light bursting at the poles can influence air chemistry thousands of kilometers away. Nitric oxide thus acts as a messenger, an invisible courier carrying information about solar storms into the realms where sunlight and weather intertwine. Through these connections, the aurora becomes more than an aesthetic wonder. It becomes a key to understanding how the sun and earth exchange energy. Solar activity does not remain confined to space. It seeps into our planet's systems, influencing temperature patterns, atmospheric circulation, and even long-term climate cycles. The sun's magnetic field pulses in complex rhythms, releasing storms that inject energy into Earth's upper layers. These injections subtly alter how heat moves around the globe, affecting winds and temperatures far from the poles. Scientists studying auroras are therefore not simply chasing light. They are tracing the hidden currents that bind our planet to its star. From a broader perspective, the aurora embodies harmony between chaos and order. Each display begins in silence, builds through invisible tension, then erupts into radiant release before fading back to calm. It mirrors the cycles of nature itself: birth, growth, climax, and rest. Beneath its beauty lies an intricate web of physics: charged particles spiraling along invisible field lines, atoms jumping between energy states, and vast electric currents flowing through the magnetosphere. Yet all of these processes converge into a spectacle that touches something emotional and universal in those who see it. It is a reminder that Earth is not an isolated world but an active participant in the cosmic environment, constantly shaped by the sun's changing moods. When observers stand under the aurora, they are witnessing the living pulse of a planet in conversation with its star. Each flicker of light is a word in that dialogue, each color a tone in its voice. From the earliest quiet patch of glow to the final fading arc, the aurora tells the story of energy's journey, from the heart of the sun, across millions of miles of space, into the magnetic shield of Earth, and finally into the air we breathe. It is both science and poetry, a meeting of motion and meaning, a bridge between what we can measure and what we can only feel. And when the lights vanish into darkness once more, leaving only the stars, one is left with the unshakable sense that something vast and eternal has passed through, whispering through the sky before returning to the silence from which it came. Though the effects of auroral phenomena on Earth's climate and environment are small compared to the influence of greenhouse gases or ocean currents, they remain crucial for understanding our planet as a complete and interconnected system where every exchange of energy, light, and motion contributes to the whole. Instruments aboard satellites meticulously record the amount of ultraviolet light and charged plasma that arrives during each solar cycle, while ground-based sensors monitor the ionosphere's response to those solar changes. These complementary data sets, spanning the upper atmosphere to deep space, enable scientists to build complex climate models that incorporate the subtle but persistent influence of space weather. The study of auroras, therefore, extends far beyond the beauty of the night sky. It becomes a way of tracing how the sun and earth share energy through invisible magnetic and electric pathways that shape both our immediate environment and our planetary future. Each shimmering display of light helps map the powerful currents that connect the magnetosphere to the ionosphere, revealing that every flash, ripple, and pulse in the aurora corresponds to a real electrical current flowing between space and the upper atmosphere. Ground-based cameras, all-sky imagers, and magnetic detectors track where these flows of energy enter and exit the atmosphere, producing detailed maps of the invisible highways of electricity that encircle our world. By combining these ground observations with satellite measurements, scientists can visualize how energy travels from the solar wind into Earth's magnetic field and eventually descends into the ionosphere, where it disperses in the form of light, heat, and motion. These patterns shift constantly, expanding, twisting, and contracting with each burst of solar activity, and their study is essential for predicting how space weather will affect satellites, navigation systems, power grids, and global communication networks. In this sense, the aurora is not only a natural wonder but also a living indicator of electrical activity on a planetary scale, a visible surface of a vast and orderly cosmic machine that operates silently yet reveals its structure through each flicker of color above the frozen poles. Auroras serve as natural laboratories for the study of plasma physics, the field concerned with understanding how charged particles behave under the influence of magnetic and electric fields. The same physical principles that shape the aurora also govern many of the most dynamic and luminous processes in the universe. In the thin upper atmosphere, where charged particles stream along Earth's magnetic field lines, scientists can directly observe the interactions between plasma and magnetism in real time. These events provide opportunities to test theories about how energy moves through plasma, the fourth state of matter, distinct from solid, liquid, and gas, which makes up more than 99% of the visible universe. By comparing satellite readings of particle motion with ground-based images of auroral light, researchers can model magnetic reconnection, turbulence, and wave interactions that occur on a scale accessible from Earth but representative of cosmic environments millions of light-years away. The aurora is both extreme and approachable, a naturally recurring experiment that repeats night after night across polar skies. Each event contributes new information about how plasma behaves when it is confined, accelerated, and released by magnetic fields, insights that are invaluable not only for astrophysics but also for practical research on nuclear fusion reactors, which rely on similar principles of magnetic confinement to contain hot plasma on Earth. Thus, the soft, shimmering glow above the poles becomes a bridge between the mysteries of our own planet and the physics that governs the stars. The same processes that paint the sky with curtains of green, red, and violet light also unfold in far grander and more violent settings across the cosmos. Around black holes, jets of charged matter twist along magnetic lines, releasing bursts of radiation so powerful that they outshine entire galaxies. In the atmospheres of stars, magnetic reconnection produces solar flares and radiation storms that can dwarf the energy released by all of humanity's activities combined. Even the spiral arms of galaxies follow magnetic pathways that guide energy and matter through the universe. By studying auroras, scientists gain a nearby and manageable model for understanding these immense cosmic forces. The equations describing particle acceleration, magnetic tension, and plasma dynamics remain the same whether they operate over the distance of a few kilometers or across countless light-years. The luminous ribbons that dance over Arctic nights are therefore not isolated curiosities, but echoes of the grand machinery of the universe, where magnetism, matter, and motion weave light from darkness in every corner of existence. Every aurora tells the story of an ongoing relationship between the sun and Earth. Each burst of light begins with an eruption on the sun's surface, a surge of plasma and energy that crosses the vast gulf of space to encounter Earth's magnetic shield. What follows is a dialogue between two celestial bodies, the sun offering energy, the Earth responding in graceful motion and radiant display. The patterns of the aurora record the conditions of that exchange, the speed of the solar wind, the tilt of Earth's magnetic field, the density and composition of the atmosphere above the poles. To watch an aurora is to witness this cosmic conversation written in light, to see the abstract mechanics of magnetism transformed into living motion. Scientists may interpret it as data, but anyone standing under its glow can feel the deeper truth it expresses, a reminder of connection, of belonging within a system larger than ourselves. Every shimmer and pulse carries a message that has traveled 90 million miles, whispering that Earth and Sun are partners in a shared rhythm of creation. Long before science could describe these processes, the people who lived beneath the aurora understood its significance in their own ways. Across the Arctic and northern Europe, ancient cultures told stories that infused the lights with spirit and meaning. To the Sami, Inuit, and many northern peoples, the aurora was alive, a sign from ancestors, a dance of souls, or the breath of animals that glowed against the stars. Some believed that the lights were torches carried by spirits to guide travelers home, while others saw them as bridges between the world of the living and that of the departed. Their motion mirrored the rhythms of human life, sometimes peaceful and gentle, sometimes wild and unpredictable. These stories endured because they reflected a fundamental truth, that awe and respect were humanity's first responses to mystery. Even now, in an age of data and equations, that older understanding retains power. The aurora remains a living symbol of the sky's vitality, reminding us that wonder is not erased by knowledge, but deepened by it. Many cultures also viewed the aurora as a message from the ancestors. In Inuit tradition, the lights were said to be the souls of the dead playing across the heavens, waving to their loved ones through arches of color. In parts of northern Scandinavia, people believed that the aurora carried the voices of the departed, whispering messages that could be felt but not heard. Such beliefs led to practices of reverence. People would not whistle, shout, or point at the lights, fearing that disrespect could bring misfortune. The aurora's beauty was at once comforting and solemn, a reminder that the boundary between worlds grew thin beneath its glow. Even today, elders in Arctic communities keep these traditions alive, passing down stories that blend memory and respect. While science now explains the aurora through solar winds and magnetism, it cannot replace the sense of presence and connection those stories evoke, the feeling that the sky remembers us, and that every flicker of light might be a greeting from beyond time. The aurora's influence on human imagination has been profound and enduring. It has inspired countless works of art, music, and literature. Painters have chased its fleeting hues across canvas, poets have written of its silent grace, and composers have tried to translate its rhythms into sound. Because the aurora refuses to stay still or be easily captured, it continually challenges artists to find new forms of expression. In ancient folklore, it was seen as divine fire or celestial light. In modern art, it symbolizes transformation, harmony, and the meeting of chaos and calm. Sculptors have tried to capture its motion in glass and metal. Choreographers have mirrored its fluid patterns through dance. Musicians have evoked its pulse in quiet, meditative harmonies. Each generation finds new language for the same mystery, ensuring that the aurora remains alive in human culture even in places where it is never seen. Across continents and centuries, it stands as a symbol that beauty can transcend geography, time, and belief, a universal call to look upward, to listen, and to transform wonder into creation. For early explorers and navigators in the far north, the aurora was not only a source of awe but also a practical guide. Before the invention of reliable compasses and precise maps, travelers used the heavens to orient themselves during long journeys across frozen landscapes. The shape, brightness, and position of the auroral glow changed with latitude and magnetic field strength, providing subtle clues about direction and location. In regions where the sun disappeared for months at a time, these lights became navigational aids that helped determine position when all other references were gone. Observers noticed that the arcs of the aurora stretched higher near the poles and flattened toward the magnetic boundary. Skilled travelers learned to estimate their latitude by studying these variations. Early Arctic explorers recorded meticulous notes on auroral patterns, comparing them with magnetic readings and developing some of the first maps of what is now called the auroral oval, the zone encircling Earth's magnetic poles where these displays are most frequent. To them, the aurora was both a compass and a companion, a luminous guide that helped humankind explore the last great frontiers of the planet. Even animals have been observed responding to the aurora's presence. Reindeer herds in northern regions sometimes react nervously when the lights appear, lifting their heads, stamping, or shifting uneasily as the sky above them fills with motion. Scientists are still studying whether this reaction is caused by subtle changes in electromagnetic fields or simply by the movement of light across the snow. In either case, such responses show that the aurora is not just a visual phenomenon but one that interacts with life itself, influencing behavior and perception across species. In modern times, as technology has brought us closer to understanding the aurora's mechanics, its importance has only grown. The aurora acts as a living diagnostic tool for Earth's magnetic and electrical systems. Each display provides a record of how solar energy enters and circulates through the planet's near-space environment. Scientists studying these lights are also safeguarding the infrastructure of our modern world. By decoding the signals written in the aurora's changing forms, researchers can better predict geomagnetic storms that might otherwise disrupt satellites, damage power grids, and interfere with global communication systems. In a sense, the aurora functions like a warning light on a planetary dashboard, flashing messages about the invisible forces shaping our technological civilization. At the same time, its deeper significance endures. The aurora is a reminder that Earth is not isolated but part of a living cosmic network. Every surge of light above the poles is a visible expression of connection between Earth and Sun, science and spirit, observation and imagination. Its glow is both a scientific phenomenon and a timeless symbol of unity, teaching that we exist within a web of energy that stretches from the heart of our planet to the farthest stars. Whether seen as plasma physics or as celestial poetry, the aurora continues to speak in the oldest and most universal language of all, the language of light, movement, and wonder. Some reindeer stand motionless, their ears twitching at unseen signals, while others begin to move in slow, circling patterns as if guided by invisible currents. Scientists who study animal behavior believe that these reactions might be linked to subtle shifts in the electromagnetic environment that accompany strong auroral activity. The same charged particles that paint the sky with curtains of green and violet could also influence the ways animals sense vibration, sound, or static electricity. Indigenous herders, whose lives have long been intertwined with these northern creatures, have noticed such reactions for generations, interpreting them as quiet omens that the heavens are stirring. While humans cannot feel the faint electric breath of a geomagnetic storm, the reindeer seem to perceive it instinctively, their heightened sensitivity possibly stemming from their extraordinary vision, which extends into the ultraviolet range. Through those eyes, the aurora may not appear as a distant glow across the horizon but as a living shimmer woven through the air itself, close, alive, and breathing. Technology, too, grants humans a similar extension of perception. Cameras, unlike our eyes, can see auroras even when the night appears dark. Sensitive digital sensors capture the earliest whispers of light long before stars emerge, recording ghostly arcs invisible to the human eye. Photographers who brave polar nights often set their cameras to record long time-lapse sequences, revealing faint, ethereal traces that bloom hours before any visible display begins. These subtle emissions occur when only a few energetic particles drift down into the upper atmosphere, their light too dim for our rods and cones to perceive. Yet the camera, patient and precise, gathers every stray photon, building a record of the aurora's hidden beginning. Scientists use the same techniques to monitor the sky continuously, tracking small fluctuations in brightness that signal changes in the magnetosphere. What appears to us as a sudden eruption of color is, in truth, the visible crescendo of a much longer, quieter symphony unfolding in darkness. Through such instruments, technology expands the reach of our senses, allowing us to detect the first silent whispers of the storm before the heavens burst into song. From the cold expanse of space, Earth's aurora takes on an even grander form, a glowing green ring encircling the poles like a crown of fire. Astronauts aboard the International Space Station often describe it as a living halo, a luminous veil stretching for thousands of kilometers across the planet's curved horizon. Through the thin edge of the atmosphere, they watch the light shimmer and pulse, brightening where Earth's magnetic field funnels charged particles most directly toward the surface. The view is breathtaking, a radiant band swirling against the velvet blackness of space, the blue glow of Earth faintly visible beneath. Time-lapse recordings from orbit reveal the aurora expanding and contracting, curling and flaring like a great organism inhaling and exhaling. For those who witness it, the experience redefines perspective. The aurora ceases to be a phenomenon above Earth and becomes instead a visible part of the planet itself, a place where Earth and the Sun meet in continuous conversation. Even from millions of kilometers away, spacecraft passing beyond the Moon can detect the signs of this glow. Instruments aboard distant probes register ultraviolet flashes and bursts of radio waves emanating from Earth's magnetic poles, revealing the aurora's presence even when the planet appears as a faint, pale dot. These signals pulse in rhythm with solar activity, allowing scientists to measure how much energy our world absorbs from the Sun. By studying these emissions, researchers can compare Earth's magnetic defenses with those of other planets, learning how magnetospheres act as shields against cosmic radiation. The fact that our aurora can be sensed across such immense distances demonstrates its strength, a luminous heartbeat that identifies Earth in the vast silence of space. In that emptiness, the planet speaks not only through reflected sunlight but through its own magnetic breath, a faint, persistent glow that marks our presence in the cosmic dark. This same natural wonder carries lessons for the future of human technology. The physics that governs the aurora is closely related to the processes inside experimental fusion reactors, where plasma, matter stripped of its electrons, is confined by magnetic fields and heated to extreme temperatures. Both environments rely on the movement of charged particles and the release of energy when magnetic lines reconnect. By studying how these auroral particles behave and how their collisions unleash bursts of light and power, scientists gain insight into how to control plasma on Earth. Such understanding is essential for achieving stable nuclear fusion, the same reaction that powers the stars. In this sense, the aurora becomes more than a spectacle, it becomes a teacher. It shows how invisible forces twist, tangle, and release, revealing how energy can be stored and harnessed safely. The knowledge drawn from this celestial classroom may one day allow humankind to create sustainable fusion energy, drawing light not from the distant sun but from the controlled fires of our own design. To stand beneath the moving aurora is to feel a profound connection between the Earth and the sun. The air vibrates faintly with energy that began 90 million miles away, traveling across space as a wind of charged particles until it was caught and guided home by Earth's magnetic field. Beneath one's feet, the ground quietly responds, conducting weak electric currents that mirror the patterns above, creating a hidden dialogue between the heavens and the earth. Every flicker of light is an expression of this conversation, a visible translation of forces that bind our planet to its parent star. In those moments, abstract physics transforms into poetry written across the sky, a reminder that we live within the influence of a living star. The boundary between cosmic and earthly seems to dissolve, revealing the aurora as a bridge between two realms, one of solid matter and air, and another of plasma and fire. Beyond its beauty, the aurora is a window into the architecture of the universe. Magnetic fields like Earth's extend across the galaxy, threading stars and planets into a vast, invisible web of energy. Our planet's lights are merely one small node in this cosmic tapestry, a bright knot in the immense electromagnetic network that connects all celestial bodies. The same currents that flow through our skies continue outward into space, merging with the solar wind and ultimately with the interstellar magnetic fields that shape the Milky Way. By studying the aurora, scientists trace these interconnections, learning that space is far from empty. It is alive with motion and structure, a fabric woven from charged particles and light. Each ripple in the northern sky is linked to forces millions of kilometers away, reminding us that Earth is not an isolated sphere but an active participant in the cosmic dance. To watch the aurora is to glimpse our place in that vast system, to recognize that our planet breathes within the living electricity of the universe. Each shimmer in the sky tells a story that begins on the sun. When a charged particle, an electron born in the heart of a solar storm, is hurled into space, it embarks on a journey across millions of kilometers. Guided by magnetic lines of force, it travels through the solar wind until it encounters Earth's magnetic shield, which captures and directs it toward the poles. There, in the rarefied air of the upper atmosphere, it collides with an atom of oxygen or nitrogen, transferring its energy in a fraction of a second. For that instant, the atom glows, releasing light that falls to Earth as color: green, red, purple, or blue depending on the altitude and gas involved. What we see as a slow, drifting wave of light is actually the combined brilliance of countless microscopic collisions, each one a fleeting encounter between a particle from the sun and an atom from our planet. These flashes of contact turn the invisible exchange of energy into visible wonder, proving that even the smallest events in the universe can paint beauty across vast distances. When the sun releases a powerful burst of plasma, a coronal mass ejection, the solar wind surges forward with immense speed and energy. As this torrent slams into Earth's magnetic field, it compresses and disturbs the field lines, injecting torrents of charged particles into the magnetosphere. The faster and denser the solar wind, the stronger the resulting magnetic storm, and the more intense the aurora becomes. During these grand events, the sky itself seems alive with motion, the colors deepening and expanding until they fill the entire dome of night. Curtains of green ripple like silk, streaks of red and violet rise above them like flames, and the light grows so bright that it casts shadows across snowy ground. Instruments aboard satellites detect surges in particle energy, And even on the surface, electrical systems may register faint disturbances as the planet's magnetic environment vibrates. Witnessing such a storm is to see the sun's power made visible, a direct link between the glowing surface of a distant star and the illuminated sky of Earth. In the darkest corners of the planet, where human light never intrudes, the Milky Way usually stretches overhead as a pale, starry river. Yet when a geomagnetic storm reaches its peak, even that ancient starlight fades before the brilliance of the aurora. For a few unforgettable hours, the universe reverses its balance. The light of our own planet outshines the distant constellations. It is in such moments that the aurora becomes more than an atmospheric event, it becomes a statement of connection and continuity, a visible thread tying together Earth, Sun, and space. The dance of charged particles across our skies is the ongoing signature of a relationship that sustains life itself, reminding us that every heartbeat, every breath, every flicker of light in the dark night is powered by the same cosmic forces that create the aurora's glow. The entire sky can sometimes pulse with immense waves of green and crimson light so bright that the landscape below emerges in ghostly detail, revealing snowfields, mountains, and frozen lakes bathed in shifting hues that seem to breathe with the planet itself. During these moments, the night transforms into a living canvas, and shadows move as if the very world were exhaling light. Historical records from explorers, sailors, and travelers describe nights when the aurora was so brilliant it illuminated ship decks and allowed people to read by its glow, the air alive with a quiet hum of unseen electricity. Modern cameras confirm that such storms can make the upper atmosphere shine more than 100 times brighter than usual, turning night briefly into a mirror of the day. For a few rare hours, the balance of the cosmos reverses. The radiance born from our own sun overwhelms even the ancient light of distant galaxies, a vivid reminder that our star still possesses power beyond measure. Yet not every aurora dances wildly across the heavens. Sometimes, it rests in a still, unwavering glow that stretches like a soft arc along the horizon. These quiet auroras shimmer faintly but hold steady, as though nature itself has reached a state of perfect equilibrium. Scientists have learned that such calm displays occur when the flow of solar particles into Earth's magnetic field is smooth and continuous rather than turbulent, creating a steady glow instead of flickering curtains. These silent moments often arrive at the end of a great magnetic storm, when the Earth's magnetosphere has released most of its tension and settles into balance once again. The tranquil light that remains lingers for hours, a soft exhale after immense cosmic exertion. To those watching, it feels less like a spectacle and more like a companion, gentle and reflective. These still glows remind us that beauty does not always require motion or intensity. It can also dwell in peace, in the serenity that follows chaos. Beneath this calm surface, however, powerful forces continue to flow. The faint light of a quiet aurora traces the outlines of vast, invisible plasma currents, electric rivers that move between the magnetosphere and the ionosphere. The arcs and bands in the sky are the contours of these hidden streams, mapping where energy flows and fades. Scientists use such observations to study how Earth's magnetic field reorganizes itself after storms, uncovering patterns of balance that would otherwise remain unseen. Even when the sky appears tranquil, the physics at work are monumental. The glow above marks the visible edge of enormous cosmic forces, proof that even the gentlest light can trace the movements of powers greater than imagination. Auroras are not unique to Earth. Far away on Mars, faint glimmers have been recorded above regions where ancient magnetism still lingers in the crust. Unlike Earth, Mars no longer possesses a global magnetic field. Its once mighty core cooled long ago, leaving behind isolated patches of magnetism locked into its rocky surface. When the solar wind collides with these pockets, the thin Martian atmosphere flickers with brief auroral light. Instead of forming a single ring near the poles, as on Earth, Martian auroras appear as scattered glows across the planet, their ultraviolet flashes invisible to the human eye but captured by orbiting spacecraft. These lights reveal the remnants of a magnetic past and tell the story of how the planet once shielded itself from solar radiation before losing that protection. Each brief flicker on Mars marks a place where ancient forces still breathe, where echoes of a once living magnetic field survive. From such discoveries, scientists piece together the planet's evolution, learning how atmospheres change when their magnetic shields fade and solar winds strike directly. Even Venus, wrapped in perpetual clouds and lacking a strong magnetic field, displays aurora-like phenomena. When powerful bursts of solar wind reach the planet, they slam into its thick atmosphere and produce faint emissions of light on the dark side, high above the swirling layers of acid clouds. These lights, though hidden from the surface, have been observed by orbiting spacecraft as flashes of green and ultraviolet glows that ripple after intense solar events. The process is different from Earth's, guided by electric currents flowing through the dense ionosphere rather than by a planetary magnetic field. Yet the result is remarkably familiar, a luminous dialogue between a planet and its star, showing that auroral processes can exist anywhere energy meets matter. Even in a world perpetually veiled in cloud, light still finds a way to write its story across the sky. Farther from the Sun, the gas giants host auroras of unimaginable scale. Jupiter's immense magnetic field produces auroral displays so powerful they could vaporize spacecraft if approached too closely. Its polar regions blaze in ultraviolet light as charged particles from the solar wind and from its volcanic moon Io are accelerated along magnetic field lines into the planet's atmosphere. These Jovian auroras pulse and flicker in rhythm with the planet's magnetic storms, sometimes lasting for days and stretching across areas larger than Earth itself. Saturn, too, glows with its own mysterious light, its auroras synchronized with bursts of radio emissions from deep within its magnetosphere. Each planet provides a unique laboratory where scientists can study how magnetic fields, atmospheres, and solar winds interact. By comparing these alien auroras to our own, researchers begin to understand how energy flows throughout the solar system, how stars shape their planetary families, and even how worlds beyond our reach might behave. The study of auroras extends even farther, to the realm of exoplanets orbiting distant stars. When astronomers detect faint radio or optical signals resembling auroral emissions from those far-off worlds, they are not merely observing light. They are reading a kind of fingerprint. These signals reveal a planet's magnetic strength, the nature of its atmosphere, and sometimes even the possibility of habitability. A strong magnetic field protects a world from its star's radiation, preserving its air and water. To detect an aurora around an exoplanet is therefore to glimpse the invisible handshake between that world and its sun, a connection that speaks of both power and protection. Across the universe, similar lights may shimmer unseen above alien horizons, glowing in colors no human eyes will ever behold, yet still performing the same cosmic dialogue that links energy to life. Though the light of an aurora may last only moments, the story it tells stretches back billions of years. Each photon of green or crimson that descends from the sky represents an atom's brief excitement, lasting less than 1,000th of a second before returning to rest. Yet the energy that makes that flash possible originates deep within the heart of our star, in nuclear reactions that have burned since long before Earth was born. The sunlight that warms our days and the solar wind that powers the aurora are both children of the same ancient fire, hydrogen atoms fusing into helium, releasing energy that crosses space as both warmth and electricity. Every flicker of auroral light is thus a message from the distant past, a visible echo of creation itself. It carries within it the memory of the cosmos, a connection stretching from the birth of the sun to the breath of life on Earth. Each spark is a fragment of the universe's ongoing story, a reminder that the energy that illuminates our sky tonight began its journey billions of years ago in the heart of a star. To watch the aurora is to witness that history made visible, to see the breath of the sun meeting the soul of the earth. The solar wind, a constant stream of charged particles exhaled by the star, rushes outward across the void until it finds the embrace of our magnetic field. There, Earth responds with light, sending back a soft, luminous reply. Between the two exists a relationship older than life itself, a rhythmic exchange of energy written in color across the sky. Every auroral curtain, every ripple and fold of light, is part of that dialogue, a symbol of giving and receiving, of creation and reflection. The lights curve and billow like visible breath, while below, their glow shimmers across snow, water, and ice. To stand beneath such a sky is to feel the world not as separate from the universe but as part of it, to sense that warmth and shelter are joined in one cosmic rhythm. When the final glow fades, when the sky darkens again to reveal the silent stars beyond, the memory of the aurora lingers like an afterimage of the divine. The air grows still, the landscape resumes its shadowed calm, but above, invisible currents continue to drift through the upper atmosphere, whispering through the edge of space. These faint, unseen flows carry the last traces of energy from the sun's great breath, reminders that the dialogue between star and planet never truly ends. Every aurora, whether wild or still, whether shining on Earth or flickering faintly above Mars or Jupiter, tells the same timeless story, that we live in a universe of connection, where every light is born from energy shared, and where even the coldest night carries the warmth of creation. The aurora is not just a spectacle of color but a reflection of existence itself, a luminous heartbeat that binds our small blue world to the heart of the sun, to the past of the stars, and to the infinite conversation of the cosmos. The same forces that create the aurora, the invisible currents of charged particles and magnetic fields, still hum gently within you, steady and enduring, a quiet resonance linking your very being to the distant heavens. You are made of the same atoms that light up the northern night, elements forged in the cores of ancient stars that once blazed with brilliance across the cosmos, scattering their energy through space to form the matter that now composes planets, oceans, mountains, and life itself. Watching the aurora is more than observing a natural spectacle. It is a reminder that you are part of a vast, interconnected universe, bound through light, motion, and time to the sun, the planets, and the farthest reaches of space. Each shimmer, fold, and ripple of color across the Arctic sky is a reflection of forces that also pulse within you, a visible echo of the energy that flows silently through every atom of your body. To witness this quiet dance of light is to remember that the cosmos is not distant or separate but intimately woven into your existence, that the rhythm of solar wind and magnetism mirrors the rhythm of your heartbeat, the ebb and flow of breath, the pulse of life. Just as electrons born in solar storms race across millions of kilometers to meet Earth's magnetic field, the building blocks of your body traveled across billions of years, through supernovae and nebulae, guided by the same cosmic laws that shape the aurora, arriving here to give form to consciousness, awareness, and the capacity to perceive beauty. The northern lights, in their majestic and fleeting glory, are therefore not merely a natural phenomenon but a mirror reflecting the unity of all creation, a bridge between the tangible and the infinite, the material and the sublime. Their glow whispers of the invisible currents that link all matter, the subtle magnetic and electric dances that animate worlds, guide planets, shape atmospheres, and energize stars. Beneath their luminous curtains, the aurora reveals the choreography of the universe, where every photon, every particle, every magnetic line of force participates in a symphony that spans from the heart of the sun to the edge of interstellar space, and every observer is a participant in that cosmic rhythm. To sit beneath it is to feel simultaneously infinitesimal and immense, to sense the grandeur of billions of years of stellar evolution mirrored in a single luminous moment, and to understand that the light that flickers above the poles is a note in the endless song of creation, a pulse in the living web of energy connecting Earth to the cosmos. As the colors fade in your vision, they leave an imprint in your mind that lingers, a memory of the sublime interplay between power and calm, turbulence and balance, chaos and serenity, the celestial and the terrestrial entwined. This luminous display teaches that even the smallest collisions, the briefest sparks of energy, can produce beauty and meaning on a scale far beyond human comprehension, that the laws governing plasma, magnetism, and motion shape not only the aurora but the stars, the galaxies, and the very atoms of your being. In that sense, to watch the aurora is to watch yourself in miniature, the energy of the universe refracted through both sky and soul, a gentle reminder that nothing exists in isolation, that your life is bound to the sun that warms the earth, to the magnetic fields that protect it, and to the atoms and forces that have traversed the eons to bring you to this moment. The soft shimmer of green and crimson across the night, the calm arcs and the wild curtains alike, are all messages in a language written by nature itself, telling of connections, exchanges, and relationships that transcend space and time. They remind us that life, matter, energy, and light are all part of a single continuum, that every heartbeat and every breath is an echo of processes that animate the universe. Each aurora is a conversation between star and planet, a dialogue of giving and receiving, A rhythm that spans millions of kilometers yet resonates within your chest, uniting the observer with the observed, the microcosm with the macrocosm. The experience is not merely visual but existential, awakening an awareness of belonging, of participation in a story that began billions of years ago and continues through every living moment. Standing beneath the northern lights, feeling the hush of polar night and the tremor of invisible currents in the air, you sense the unity of matter and energy, the interweaving of time and space, and the continuity of creation. The sky's colors may fade, yet their lesson endures, that you are a child of the cosmos, composed of stardust and cosmic energy, connected to every particle that dances in the aurora, to every current that flows in the sun, and to every life that breathes on earth. In that understanding, there is peace, a calm as deep and profound as the Arctic night itself, a gentle settling of the mind and body into the rhythm of the universe. Let your breathing slow, let your thoughts drift with the fading colors, allow the calm to spread through you like falling snow, a quiet meditation on connection, energy, and existence. The aurora, in its fleeting brilliance, leaves behind a gift, the awareness that even as the lights vanish from the sky, the same forces that made them shimmer continue to flow within you, steady and enduring, linking you in a chain of cosmic heritage that stretches from the birth of stars to this very moment. And in that reflection, you are reminded that life itself is luminous, not only in what is seen but in the unseen currents that bind us all, and as the final glow dissolves into darkness, you rest beneath a sky that has whispered the secret of your place in the living cosmos, carrying with it the soft echo of eternity, the quiet hum of creation, and the gentle pulse of the universe itself, leaving you in a state of calm and wonder, ready to drift into sleep as part of the vast, interconnected rhythm of existence.